Okay, welcome to the next substrate recipe tutorial here, and we're going to continue talking about storage. We talked about simple storage before, where we were just storing one variable in the storage system, which, probably doesn't go very far because we can only store one thing in it. Of course, unless we store like a vector and put it in and out of that, but that's not necessarily the best way to do things. And instead, we're going to be looking at using this storage map, which is very popular. And it's one of three methods of storage here. And we're looking at the Substrate Developer Hub. We're looking under storage, and we can roll down here to storage items. And in it here, the storage palette gives us three types of storage. We have the storage value, which is the simple one, which we looked at first. We're going to be using this storage map next. And lastly, we will look at the double map. Now there also, I see here in the tutorial, I've never actually used this, so I'm not sure yet, but it has a storage end map. So maybe we'll try and figure that out later. Who knows? We'll see where this goes. But we're going to look at the storage map today in the recipes. And right as it says here, it says use to store a key value hash map such as a balance to account mapping. Now, what we can use the storage map for basically is it's a hash map. So if you have sort of any type of hash map that you've used before in other programming languages, it has a key value pair. So the key could be the account ID and the value could be, for example, the balance here, such as they're suggesting. Or, for example, something completely arbitrary, maybe the key is a username, such as Eric or Alice, Bob, whatever, and maybe the value is their height, right? So a key value pair. And let's see if they have any other hot tips here that we can check out. Okay, so map data structures are ideal for managing sets of items whose elements will be accessed randomly, as opposed to iterating over them. So for example, this is not the kind of thing we're typically going to be using in a for each loop or for loop. Instead, they say random, but for us, I mean, it's not really we're accessing it randomly, we're accessing it specifically. We're looking for a specific target rather than trying to iterate over everything and pick out one thing. Okay, so let's look over at the recipes. And I don't think I'm going to be using anything from here at the moment. We'll jump into the code and then come back here and talk about using a hasher. So we have different kinds of hashes here. If you're not familiar with hashes, that's okay. Just take some time to read over this after. Now I'm in my IDE. I'm using IntelliJ, but you maybe are using Visual Studio Code, which is also quite popular. I've got open the substrate recipes. I'm down in palettes, and this one comes with the recipes as it's found online. And I'm opening up simple map, and we're just going to open up the library here, LIB. I'll close off the side, roll up to the top, and it says a palette to demonstrate the usage of simple storage map. Awesome. Okay. So don't forget, if you're working with any kind of storage here, you need to, and this is version 1 of Framework, so if none of this looks familiar at all, you're maybe using version 2, but we're using version 1. And in the frame support, we need to make sure that we declare the storage here. Okay. And this, of course, needs to be declared in the runtime, and that's already been done for us. So if this declare storage is not working, then we're not, or sorry, not in the frame support, then we're not going to be able to declare storage later on here, right? But just like the simple values, we need to declare a storage macro with a little exclamation at the end, opening, closing. Then we need a trait store for module t config as, okay? And here it says simple map, but we can put whatever the name of our palette is here, is the what's the right word here? I don't want to say the baseline, the standard practice. That's the right word I'm looking for in English. Standard practice is just put the name of the palette that you're working with. So this will keep you from conflicting with other storages. Next, we are going to give the name of our storage. So this one's simple map. It's named after this palette, but it could be my friend's height, right? Then we're going to go space and get. We're going to type fn for function and my friend's height and a colon. So this part is exactly like the simple storage that we did before. There is no difference. It's declared just the same way. And this time we're going to type map to indicate this is a storage map. So this has to be specific. Then we have to type the word hasher. And what we're going to do is pass it how it's going to be hashed into the storage system. Out of the box, Substrate comes with 3 hashing systems. So let's jump back now to the recipe just to look at this. Choosing a hasher. Although the syntax above is complex, so we've already looked at the syntax, most of it should be straightforward if you've understood the recipe on storage values. We did. The last unfamiliar piece of writing a storage map is choosing which hasher to use. In general, you should choose one of the 3 following hashers. The choice of hasher will affect the performance and security of your chain. If you don't want to think about this, just choose Blake2 128 concat and skip the next section. So if you don't understand hashers well, really just stick with their advice and go with the default. But basically it boils down to is the Blake2 is cryptographically secure and is always safe to use and is reasonably efficient. It's not the most efficient, but it's reasonably efficient. Now we have the 2x64 concat. So this hasher is not cryptographically secure, but is more efficient than Blake2. So we're trading security for performance. You should not use this hasher if a chain user can affect the storage keys. Okay, go ahead and continue reading that if you want to later. And the identity hasher is not a hasher at all, but merely an identity function that returns the same value as it receives. This hasher is only an option when the key type of your storage map is already hashed and is not controllable by the user. So if you're in doubt whether the user can influence the key, just use the Blake2. Okay, so we are just going to use this Blake2 format as they suggest, because honestly, we have no idea where we're going to use this later. Okay. After that, we are going to type the return, or sorry, first the key, and then the value. So if you check the documentation of pretty much any hash map of any kind, you're going to see it's normally It's normally going to be written as K for key and V for value, just like we often usually see T for type or trait. So the key is going to be, we're going to use a specific trait is the account ID. Make sure you spell this right. And then the value that it's going to return, in this case, is going to be a U32. So if we were storing people's heights, we could probably just use a U8, to be honest. Because people are not usually, I don't know how we're going to measure, maybe meters, for example. They're not going to be more than 255 meters, I hope. Okay. So now that we have our storage declared, we can actually go ahead and use this somewhere. We'll go down and see where it's been used so far. And here's a function of it being used. It's called set single entry. And we're going to set the value stored at a particular key. So when you run this function from an extrinsic, so off the chain onto the chain using the website for now, the origin is passed automatically, but we need to pass it a specific value. So in this case, the value is going to be a U32, so it's a number. And we're going to make sure that the origin is signed, so this is a person who can actually access this. Then we're going to say the name of the storage. And sorry, I'm like horrible, I didn't check this. Copy and paste this. Let's be honest, that's how we're all doing this, because, okay. Copy and paste, and then we're going to put T for type. Colon, colon, and then the command we're going to use is insert. So that looks correct. Then open and closing, semicolon at the end. Now we're going to pass the value. So we're going to pass a reference of user. So this is actually the origin here, comma, and then we're going to pass in the value. So in this case, it's going to be entry, and it should look like this. So the user might be Alice or Bob. The entry is going to be, for example, their height, and maybe their height's like, I don't know, 1.8 if he's tall. And I'll just comment this out because we already have here. And in this case, they're going to send back an event here saying, okay, this is what we've entered, and they're going to return an okay. Go farther down. So we have another function called get single entry. So this is going to get the value out. So in this case, they are passing the origin, but they're also passing the account ID. So you could look up someone else's height if we were using the height here, which is not really what we want to do. But if you only wanted them to be able to check their own, right, we could delete this part here, and they would just pass the origin, and they would use this getter instead of the account. Like this. And in this case, I actually maybe deleted some of the code because I see it's not complete. Let's look. So it's going to get the origin, and now we're using this ensure statement, which is also a macro. And it's basically doing an error check. It's actually doing an if-then statement, or we could convert it to an if-then statement. So if this is true, so this will return a statement back if it's true or false. If it contains this key, right, then we're going to do this. Else, we're going to return an error. So this is our error here. So we don't want to do it as an if and, we can just do ensure that this is true. If it returns true, then it will just continue down the code. If it returns false, then we're going to throw this error. So this error will get returned up into the dispatch results and be sent out. So it says here, read the value stored at a particular key and emit an event when it's successful, essentially. So we'll copy and paste this because it has no event. So even if people ran this code, it wouldn't actually return an event, and therefore we would not get the information that we want. So this would have to be set to getter. And even then, actually, in this case, we are not saving the value out anywhere. So I'll leave that. We'll keep looking down. I think we're going to do it soon. Right, we can't pass the variable back that we got from the storage because we're not actually getting it out in any way here. So let's look farther down. Okay, so this is what we're doing here. Okay, same thing before. We're passing in this origin, getting the user out of it, checking to see that it contains it. If it doesn't, throw an error. Else, okay, continue down. So let the entry equal, then we're going to declare the name of the storage, type, then colon, colon, and take is the command here. So this time we're going to use take to take it out, and then pass the key. So what's the key? It's the user. We're looking up, for example, their height. And then in this case here, we're going to run our event, which is a raw event because we want to pass a variable through it, a parameter. So this, we're going to pass the user and their height, and then we're going to say OK. So if we're using dispatch results, don't forget we always need to pass OK at the end if it's successful. Otherwise, this won't run correctly. Expecting something back. So it will just continue down this chain. If you look at a lot of Substrate code here, you will find that there's very few if-then statements. Instead, they always use like a short circuit, which means that instead of going down, 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 it reaches an error state and then it will just exit out. It'll board out instead of using like branching if-then statements. Okay, let's look about another example here. So this is increase the value associated with a particular key. So here we're going to add a value when we call this function increase a single entry. So maybe I pass in the value of 5. So this is add this value. We're going to make sure the person can access this. Yep. It also happens to be the key. It's in the storage. Yep. So no errors thrown. Then we're going to get the value here from the user as the key. Then the value is the original value. You may have noticed right away, so here I'm using a get statement. So get is just going to read out the value, versus if we go up here, I used a take statement. Now take is actually going to remove it from the map. So first it's going to read it out, and then it's going to remove it all in one command. And so we want to do it this way as a take statement instead of 2 commands. And we could do it as 2 commands. And because if this function fails partway through, it won't be on 2 statements, right? Like one maybe will work and then the second one doesn't work. We want to make sure that once we've used it, it's out right away. And it's also just a matter of efficiency. Okay, so going back down, we get this value from the storage map. We save it as the original value. Now we take the original value and use a new function that you may not have seen before if you're not familiar with Rust. So we'll say like we can say my new number, it doesn't matter what we call our variable, equals. And so we're going to take this original value that we got out of the storage map and say dot, and we can say check, see if my IntelliSense jumps up and tells me. No. Okay, now it's telling me, which is a little too late. But check adds, it's basically going to try and add a value, right? So, and the value that we want to add is, we set it up as a variable here, is add this value. And if this works, then this will just continue to run. Else, we want to short circuit this. We're going to say, okay, or, and then put in our error. So again, rather than using if-then statements and then checking to see, we can do it all in one line, which is a more safe way to do this. And why would this maybe not be okay to add? Well, we could cause a stack overflow here by potentially adding a number that is bigger than a U32 can handle, and that would throw an error, which would throw a panic, which is going to be a problem for our blockchain. So we want to make sure that this value is checked possible. Otherwise, we're going to error out before we insert this new number into our blockchain, right? If we go down here, then we've got simple map and insert, and then we're going to insert the new value over top. So if we're going to have an issue, we want to book it from here because nothing has been permanently changed. That can't be undone. We want to make the insertion as close to the bottom as possible, and we want to change our database, once all the error checks have been done at the top. So typically we're going to check to see who signed in, make everything is okay, add our values, do our math, make sure that's okay, and then lastly, we want to insert. And once it's inserted, then at the very bottom, we're going to deposit the event. We're going to send out the event saying, okay, this worked, and then fire off okay, because that's going to be the last thing. So this is the simple map. Let's go back to the recipes page at the bottom and just look down and see if we missed any of these API commands. So we used, from the storage map API, we used insert, we used get, we used take, and we also used contains key. Now there are still more sophisticated ways even of manipulating the data in a storage map. that we haven't covered yet, and we'll get into some other tutorials as we sort of build our way up. So this is sort of the most basic way, like take a value, make sure we can add it and reinsert it, but we can do these in potentially even less statements. But until you know this first, that will be more complicated than it needs to be. So that is it for storage maps. This just leaves basically one common typing of map left, which we will look at in a upcoming tutorial. And that is the double storage map, which is basically a variation on what we've done here. But this storage map is pretty bread and butter, so it's good that you understand how to use this. Okay, until our next tutorial, I hope everyone is well, and I will see you again.